Okay, so let's have a look at the 2023 Higher Level Maths Leaving Cert Paper 1. And this is the first of the long questions. This is question 7. So Fiona is driving on a motorway. She passes a point A. Her speed is given by v of t is equal to the thirds t cubed minus 6t squared plus 13t plus 109, where v is her speed in kilometers per hour, t minutes after passing the point A. For t is between 0 and 5 inclusive and t is real, work out Fiona's speed when she passes point A. Okay, so when she passes point A, the time is 0. So we want v of 0. And that's just going to be putting 0 in here, 0 in here, 0 in here, which will just leave us with 109, and that is kilometers per hour. So we're mixing units here. We've got hours and minutes, but t is minutes, so we've got to put t in minutes in here, and we do end up with kilometers per hour. So okay. Let's have a look at part B then. Work out Fiona's acceleration, that is the rate at which her speed is increasing 5 minutes after she passes the point A. Give your answer in kilometers per hour per minute. Okay, so we want her acceleration. So acceleration is just going to be v prime t. So we've got to differentiate the function. When we differentiate this function up here, you bring down the 3. That'll cancel with this 3 here, and we're left with 2t squared. Bring down the t here. That'll give us minus 12t, and then we're left with 13 here. So this is her acceleration, and we want her acceleration 5 minutes after she passes the point A. So again, t is in minutes here, and our answer is in kilometers per hour per minute. So we want v prime 5, so that's going to be twice 5 squared minus 12 times 5 plus 13. So when you do that, you get 3. So that's 3 kilometers per hour per minute. So she's accelerating, her speed is increasing 3 kilometers per hour every minute. Okay, so let's have a look at C then. Find the time value of t at which Fiona reaches her maximum speed during the first 4 minutes after she passes the point A. Give your answer correct to 2 decimal places. So we want to find the time at which she reaches her maximum speed. So the way you would do that is you need to look at the 2 extreme values first. So you're looking at the first 4 minutes. So you want t is equal to 0. So we want t is equal to 0. We're going to do that first. Then we're going to do t is equal to 4. Then we'll differentiate to find if there's a maximum in there, a local maximum in there. So let's look at v of 0, t is equal to 0 first. So we need v of 0. So we've worked that already out, and that's 109 kilometers per hour. We also want v of 4. So we want to put 4 minutes in there. So that would be 2/3 of 4 cubed minus 6 times 4 squared plus 13 times 4 plus 109. Okay, now I've worked that out, and it comes out at 107 and 2/3, and that's kilometers per hour. So we have the 2 extreme points anyway. We have the speed at time 0 and time 4. Now let's look at, here is time is equal to 4. So now let's look at the differential of the equation. So we know that v dash t is, let's see, what was it, 2t squared minus 12t plus 13. So let's let that equal to 0. 2t squared minus 12t plus 13 equal to 0, to see if there's a time between 0 and 4 where there is a maximum, a local maximum. So let's see, we can't factorize this, I think. 2 13's 13, no, we're not going to be able to do that. So we're going to have to use the minus b formula, the quadratic formula. So we know that t is going to be equal to minus b, so b is minus 12, so that's going to be 12 plus or minus the square root of b squared, well b is minus 12, which we have to square, minus 4 times a, which is 2, and times c, which is 13. Got to put all that over twice a. Now, again, I've done that out, and you get 2 times. You get 4 point, I'll do it to 4 decimal places, 4.5811, and that goes on for a while. And then we also have 1.41886, 5 decimal places actually there. So these are our 2 times. So the one we're interested in is not this one because it's outside our 4 minutes. We're interested in this here. So there's a local maximum at 1.41886 minutes. So we want to find what is that maximum, what will the speed be at that particular time, to see if it's larger than these two here, see if it's a maximum speed. So let's have a look. We need to basically stick this time into our original function. So let's do that. So let's see, we want v of 1.41886. So we've got to put that into our original function then. So it's going to be 2/3 of 1.41886, and that's cubed, minus 6 times 1.41886, and that is squared, plus 13 times 1.41886 plus 109. That's our original function. So when you work all of that out, you will get a velocity there of 117.27 kilometers per hour. So which one is our maximum then? Well, we have a 109, we have a 107, and we have a 117. So this is our maximum speed between 0 and 4 minutes. So our answer then, what were we actually asked? So it says find the time at which Fiona reaches her maximum speed. So that, and give your answer to 2 decimal places. So our answer then is going to be this time here to 2 decimal places. So t is equal to 1.42, and that's minutes. Okay, so let's look at D. Use integration to work out Fiona's average speed over the 5 minutes after she passes the point A. Give your answer correct to 2 decimal places. So this is an average value type question. So we do 1 over, we're going from 5 to 0. It's in the first 5 minutes. We want to integrate from 0 to 5. And we are integrating our function, which is 2/3 t cubed minus 6t squared plus 13t plus 109. And we're integrating with respect to t. So this is going to be, let's see, 1/5 of, now again we've got to increase the power by 1 and divide by that power. So that's going to be, let's see, t to the power of 4 anyway, over 4. So 3 4s are 12. So that's going to be 1 over 6. So that's going to be over 6 here. Increase this one here by 1, so that's going to be t cubed over 3, and the 3 will go into 6 twice, so that's going to be 2 here. Increase the power here by 1 rather, to 2, so that's going to be t squared, and it's going to be over 2, so it's that there, and then we've got to increase the power here by 1, so from 0 to 1, so that's x. And we are integrating between 0 and 5. Okay, so let's do all of this. Now you got to put 5 in here instead of, I put an x in there instead of a t. That should be a t there. So let me just change that. That should be a t there. So I'm going to put 5 in here instead of all of these t's, and then put, well, if I put 0 in, all of these terms are just going to become 0. So really I just end up with 1/5 of 5 to the power of 4 over 6 minus 2 times 5 cubed plus 13 over 2 times 5 squared plus 109 times 5. And that's really it. Okay, so that's just something you can do on your calculator. Again, I worked all this out and I got 112.33 to 2 decimal places kilometers per hour. So use integration to work out Fiona's average speed. So this is her average speed over the first 5 minutes after she passes the point A. And we've given our answer to 2 decimal places. Okay, so let's have a look at the next question then, part E. Now, taking v prime t to be the derivative of v and v double prime t to be the second derivative of v prime, the first derivative of v at 1 is positive and the second derivative is negative. We're given 4 graphs A, B, C, and D. Close to where t is equal to 1. The graph of y is equal to v of t must look like one of the 4 graphs given above. Write down which graph it is. Justify your answer from both v prime 1 and v double prime 1. Okay, so we know that v prime 1, the first derivative at 1 is positive. That means the slope of our graph, the slope of our tangent at the point t is equal to 1 must be positive. So here we can see our tangent would be negative. Here's positive, so it could be b. Here the slope would be negative. Here the slope would be positive. So we could say, let's see, something like v dash 1 greater than 0 means that the slope of the tangent at t is equal to 1 is positive. Therefore, we would be looking at graph B or D. Now the second derivative is going to be negative. I don't give you a lot of space to write this, so let's hope I can get this in here. Let's see, v double prime 1 being negative means that the slope, or the slopes if you like, of the tangents around t is equal to 1 are decreasing as t increases. Therefore, we would be looking at graph B. So in other words, if we draw some tangents here, let's see, that one there is going to be positive, that's positive, that's positive. You can see there that the slopes of these tangents are decreasing. Here you can see you've got slopes of tangents that are increasing. So the second derivative being negative means that the slopes are decreasing. So I think that's just about it. I did draw or put into GeoGebra the actual graph itself. This is it here. Now we can see this is t is equal to 0, t is equal to 1, t is equal to 2, t is equal to 3, 4, and 5. So you can see at t is equal to 1 around here that this looks like graph B rather than graph D. So anyway, that's it for E. Again, it's one of those type of questions that you really want to just have a look at the marking scheme to see exactly what way they want the answer, but I'm thinking I have it covered there. We'll find out anyway when the marking scheme comes out. Okay, there is an average speed zone on the motorway starting at point A and ending at point B. The distance from A to B along the motorway is 10 kilometers. So let's say we have point A here, we have point B here, and we know that this is 10 kilometers. cameras record the time taken for each car to travel from point A to B. Each car's average speed then from A to B is calculated. So calculate the time it takes you to get from A to B. They know it's 10 kilometers, so they can work out your average speed. So work out the minimum time in minutes that a driver could get from A to B while not driving above 100 kilometers per hour. So here we know this is just a speed, distance, time type question. So we know that speed is equal to distance over time. We know that time is therefore equal to distance over speed. We know that the time is going to be equal to the distance, which is 10 kilometers, over the speed that we want is 100 kilometers. So that's 1/10 of an hour, or 6 minutes. So our answer is basically 6 minutes. Work out the minimum time in minutes. So this is our answer here, 6 minutes, that a driver could get from A to B while not driving above 100 kilometers. So if it took them 5 minutes, well, that's going to be above 100 kilometers per hour. If it took them 7 minutes, well, that's going to be below 100 kilometers per hour. Okay, so that's it. Let's have a look at is this the last part? I'm not sure. Let's see. Rowan drives from A to B. He passes a point A at a constant speed of 120 kilometers per hour. After 2 minutes driving at this speed, he starts to decelerate. So basically what's happening here is you have something like this. Let's say this is speed here in kilometers per hour. And this is time along here. I'm going to do it in hours for the moment. And let's see, we've got 120 anyway, kilometers per hour. After 2 minutes driving, so what happens is he goes along here. After 2 minutes, then he starts to decelerate until he gets to B. Let's say B is here. This is point B here. So let's see, what do they ask? He starts to decelerate, reducing his speed at a constant rate until he reaches B. Overall, his average speed is, so the average speed is 100 kilometers per hour. Work out Rowan's deceleration, give your answer in kilometers per hour per minute. So let's work out the distance that he travels in the first 2 minutes. So in other words, here's going to be 2 minutes, and out to B here, that's going to be 6 minutes. Takes 6 minutes in total. However, if we're looking at hours, this is going to be 2 over 60th of an hour, and this is going to be 6 over 60th of an hour. So this is going to be in hours here. 6 over 60. So this is going to be 4 minutes along here. So 4 out of 60, 4 over 60 of an hour, if you like. So that's the time it takes him to decelerate. So we want to work out this distance here first, the distance that it takes him to travel at constant speed. So he's traveling at a speed of 120 kilometers per hour. The time is 2 minutes, or 2/60ths of an hour. So we have speed is distance over time. We want distance, so that just means distance is equal to speed times time. So the speed is 120, the time is 2/60ths of an hour. So the distance is 4 kilometers. So the distance from here to here, in other words, that distance there is 4 kilometers. What you may realize here, and this is really more of an applied maths type question, but anyway, if you have a speed of 120 kilometers per hour and you have a time of 2/60ths, really all you've got to do is multiply the two, length by width. You're getting the area of this rectangle here, in other words, to give you the distance. In other words, the area underneath the curve here will give you the distance. So let's have a look at this part of the graph here now. So we're going to look at the distance traveled decelerating, we know is going to be 6 kilometers. This has to be 6 kilometers, as it's 10 kilometers in total. So in other words, if you like, the area underneath this part of the graph here is going to be 6 kilometers. So let's have a look and see what we can do with that. We've got, we know that he starts here at 120 kilometers per hour. If we could work out the speed that he reaches B at, then we can work out the acceleration or the deceleration, if you like. So we've got to work out this value here. Let's call it x. So we got to work out this value here, what speed he was actually passing B at. So let's do that then. What we can do here is look at this area here and this area here. We know it equals 6. So let's see, we have this distance here, which is 6/60ths minus 2/60ths, which is 4/60ths. This is 4/60ths along here. So we have 4/60 multiplied by x. That'll give us the area of this rectangle, length times width. We want this area here now as well. We'll add that on. So let's see, that's a triangle. So it's going to be half the base, which is half 4/60ths, times this distance along here, which is 120 minus x. And we know when we do all of that, we should get 6. Okay, so let's work all this out. We have 4/60 times x plus a half times 4/60 times 120. Well, that will be 60 and 2, 120 is 2, 2 4 is 8. Then minus 4/60 times x, again equal to 6. Now let's see, we have 4/60x plus a half of 8 is 4, minus 2/60 times x, the 2 will go into the 4 here, and that equals 6. Okay, so let's see, we have 4/60ths minus 2/60ths, that's 2/60ths. I'm going to take this 4 and bring it over to the other side, so that'll give me, so remember that's x here, and bring the 4 over here, that'll give me 2. So let's just divide by that fraction. That gives me x is equal to, multiply by 60, I get 120. Divide by 2, that'll give me 60. So that's kilometers per hour. Okay, so in other words, when he reaches here, he's doing 60 kilometers per hour. So now we can work out the deceleration. I think that was the question. Work out Ronan's deceleration. So we know now that he goes from 120 kilometers per hour to 60 kilometers per hour, and it takes him, let's see, 4 minutes. It takes him 4 minutes. So in other words, he goes down 60 kilometers per 60. I'll leave out the minus actually just for the moment. So 60 kilometers per hour in 4 minutes. So he reduces his speed by 60 kilometers per hour in 4 minutes, which is equal to 60 divided by 4, which is 15 kilometers per hour per minute deceleration. So you can write it like that, or minus 15 kilometers per hour per minute. So either way is fine. Okay, so that would have been a tricky enough question, I think. Not so much for applied math students, but there's maybe another way of looking at this, but this is the way I would do it anyway. So anyway, that's it for this question.